Alright, biology kids, let's go over photosynthesis one more time. Please feel free to stop the video at any time, Mr. Stace, or whoever is subbing today. You could also stop the video, rewind, pause, let students catch up, ask questions whenever you'd like. So yesterday in class we learned the balanced equation for photosynthesis. We know that you're going to put carbon dioxide and water in. It uses sunlight and chlorophyll to manipulate those two molecules and to change them into C6H12O6, which stands for glucose, and then oxygen molecules as well. So when this happens, it's kind of magic, at least in my opinion, it's kind of magical, because you're turning that light, that intangible thing, into a chemical that you actually eat, build plants with, that kind of thing. So the first step is something called the light reactions, and of course it is using sunlight and molecules found in chlorophyll. So to explain this, I gave you guys this horribly embarrassing analogy, which may or may not make sense to you. So I'll tell the story one more time. Once upon a time, there was this fictional world called Chloroplast, and there were these two guys that were extremely bored in that world. They were hanging out in this place that was supposed to be a cool club. It was called PS2, but it was really boring until somebody turned the lights on. And then, of course, those two guys started dancing. They got so excited, and they started dancing so crazy that they got kicked out by a bouncer. But now the club is kind of sad and lonely, and it can't find anybody who wants to rejoin the club just out there, so it has to go to a nearby pool, to a source of water, and say, hey guys, come join our club. And they're like, no, we don't want to join your club. And so it's like, fine, I'm going to rip you out of the water and force you into my club. And now the club is full again, so it's totally happy and satisfied. In step 3, those two crazy electrons, those guys right there that are dancing, they're really annoying. They're really irritating. And because they're so negative, everybody that they bump into becomes negative. And in order to fix that situation, make everybody happy and stable again, we have this whole crowd of happy people that are attracted to the commotion. And they say, it's okay, Grandpa, you're still awesome. We like your wrinkles. We like your bad jokes. We like your goofy tie. And that makes him feel happy and positive again. And so all is well, and everybody moves along. In step 4, those original guys who were so excited, well, now they're kind of running out of energy, until they see, off in the distance, there's another club, and that club is called PS1. And PS1 is so exciting, it's got lots of light, lots of energy, so they get in there, and immediately they start dancing, getting really excited, and going crazy again. And they get so crazy that they get kicked out another time. Now the only problem now is that they've got this reputation. They're kind of the bad guys in the story. They're super negative. They keep getting kicked out of clubs for being too excited. So as soon as they get kicked out this time, they get captured. And the PD, the police department, captures them. And it's arresting them. It's taking them into their car. And they're taking that negative situation and isolating it. But then off in the distance, the police officer sees this girl. And he says, oh, there's the love of my life. I would give anything if she and I could become a couple, that we could bond. I really think we could, but, you know, she just thinks I'm so unattractive. She's just not even interested. And Homer, using his one brain cell, actually gets a bright idea, and he says, hey, if we were to help you get the girl, if we were to make you more attractive and you could get the girl, would you let us free? And the cop is like, yeah. So they do. Those two electrons help the chief become attractive to the girl, and now they're a couple happily ever after. Yay! But what happened to all of those happy people that were chasing around Homer and his friend and trying to fix all the situations? Well, the situation's over. They've moved on. They're done. They're not really making a lot of people grumpy anymore. But all those happy people are still hanging around. And now they're at the end of a dead-end street with nowhere to go. So how do they get out of there? Imagine that there's a little turnstile, like the ones you go through at amusement parks, and all of those people are running through there, and every time it turns, it's like turning a windmill, and that's generating energy. So our story has a doubly happy ending. Happy ending number 1 is for the couple who got together now because of Homer, and happy ending number 2 is for the rest of this land of Chloroplast because we're getting free energy out of the deal. So that's kind of cool. So here's our story. Where's the science? Yesterday, we took notes on this. We took notes on what's in a chloroplast, because we said this is happening in the fictional land of chloroplast? Well, a chloroplast is made of these three components. Inside step 1, we're talking about PS2, and it's not really a club. It's an area of pigments, which are chlorophyll, and proteins. And all of these little centers of pigment and protein are inside of chloroplasts, and they're there to capture sunlight. When the sunlight is absorbed, those electrons that are inside get really excited. They actually kind of vibrate back and forth until they bounce right out of that molecule of chlorophyll. And they're going to go to something called the ETC, the electron transport chain, which is just a series of other molecules that can take electrons and move them from place to place. Now, like any molecule that's missing electrons, it's very unstable. So PS2, that club, is missing electrons. It has to replace them. Now, electrons aren't just usually floating around somewhere. You have to get them from something. And since chloroplasts have water in the stroma, they're going to split those water molecules to get 2 more electrons to replace the ones that were lost. When you split water, however, you also are going to get 2 hydrogen ions. Look at that charge on hydrogen. Positive. We talked about positive people, if you remember. That'll come in handy later. So we've got these positive ions. We're also giving off oxygen gas. Think back to your photosynthesis equation. 6CO2 plus 6H2O in the presence of sunlight and chlorophyll gives... Isn't oxygen one of those things? That's where it comes from. So PS2, our club, or our photosystem, is stable again because it's now got its 2 electrons back. But what happened to those 2 guys that we kicked out? They are moving down the electron transport chain, and electrons have a negative charge. So every protein that they become attached to is now negatively charged, and we have to fix that because it's unstable. So there's going to be some positive hydrogen ions that are going to follow the electrons and try and smooth everything over, try and make everything balanced, make everything electromagnetically stable again. So they're going to continue following those 2 electrons as they move down the electron transport chain, and as they do that... Oh, sorry, my computer's loading. Okay, as they move down the electron transport chain, eventually they're losing energy. They get to photosystem 1. And photosystem 1 is very similar to photosystem 2, so they're going to absorb more energy from more sunlight, and they get super excited, and they leave. So the electrons in this case are getting their energy from sunlight in another photosystem. Now you might want to stop here and go like, whoa, Johnson, they're out of order, can't you count? And I would say, yes, I can count. I taught my 3-year-old. So I know that 1 comes and then 2, but these photosystems were named in order of when they were discovered. So we thought everything started in photosystem 1. And then we're like, wait a sec, rewind, because they had to come from somewhere. Where are these electrons coming from? And so we had to do more experiments and a lot of boring science, and then we found out, oh, wait, there's another one back there. And we're going to call that one photosystem 2, because we discovered it second, but yeah, it's confusing. So start with the PS2, and then go to PS1. Kind of like when you're playing PlayStation. Wouldn't you rather play a game on a PS2 than a PS1? So you're going to start on the PS2, and then go to the PS1 if the PS2 is broken or something. Step 5, we're going to form a molecule called NADPH. And NADPH is what happens when you put these 2 together. If you look, NADP plus is what molecule I'm representing here with the cup. I know it's a really lame attempt, but DP, PD, it's the best I got. I mean, if you come up with something better, tell me. So he is a positively charged molecule, and he's after this girl here who is a hydrogen, which is also a positively charged molecule. Those 2 can't get together. They won't be attracted to one another. Just like when you try and put 2 magnets together, but you rotate them so it's the wrong end, they're just going to repel each other. So he can't bond to that girl of his dreams without some help. So, because electrons are negative, they allow this positive charge and this positive charge to be attracted. They're kind of the glue that bridges the 2 together. So what happens here is that the chief gets his makeover. Oops, I'll move that back. The chief gets his makeover, and he becomes this super attractive dude, and now these guys form the couple. That couple molecule is NADPH. You don't have to know what that stands for. And no, it's not really a chemical formula, but it is a really important energy molecule. We need this to make sugar, so you're going to hear about this molecule again. The last step is the most important step. This is how plants generate energy to do everything else that they do. So what they're going to do here is they're going to use all of those hydrogen ions that were following around those negative electrons, and we're going to use them and push them all through an enzyme called ATP synthase. Now the name tells you exactly what it does. It synthesizes or makes ATP. And ATP is the most essential, most basic energy molecule that all of our cells use. And we call it this thing called chemiosmosis. You guys know about osmosis. That's the movement of water molecules across a membrane from high to low concentration. Now, chemiosmosis is simply taking hydrogen ions, instead of just water, from high to low concentration across a membrane. So the same thing is happening. In this case, however, because they're going through an enzyme, that ratcheting motion or the spinning motion that is occurring with that enzyme is generating molecules of ATP, our energy source. And that's very, very good for your cells. That is a very happy ending to our story because we all need ATP. In closing, here's our balanced equation for photosynthesis one more time. Get used to it. So we've got 6CO2 plus 6H2O in the presence of sunlight and chlorophyll. They're going to give us C6H12O6 glucose plus 6O2. And this makes Homer very, very happy because we're using water, splitting the water molecules apart, using sunlight energy shining on photosystem 1 and 2 to excite electrons and give us energy that we're going to need to make sugar, which is delicious. So, the rest of your day, Mr. Stace is in charge. Please work well for the sub, and if you have any questions, you guys know how to reach me. Good luck.